Welcome back to Tech Stack for all you tech enthusiasts. Most front-end applications today are built using React. From small business websites to large-scale dashboards, React has become the standard. So if you want to work in front-end development, learning React is not optional anymore. This is part 1 of my React 19 tutorial, and the goal here is simple: build a strong foundation. In this part, we started from zero. We installed Node.js, VS Code, and created a React project using Vite, so you understand how a modern React app actually starts. We broke down the folder and file structure. What index, main.jsx, and App.jsx do. Why package.json exists. What Node_modules really is. And how the src folder is organized. Then we moved into components. Fragments. Components in the same file and in separate files. We will cover much more, so let's get started. So first, let's start with the React definition. React, also known as React.js, is an open-source JavaScript library used to build dynamic and interactive user interfaces. Now let's understand SPA and the virtual DOM. SPA, single-page application. An SPA loads only one page. The page does not reload when you click, so it feels fast. Virtual DOM. The virtual DOM is a copy of the web page. React updates only the parts that change, making the site faster. Let's understand SPA with an example. On the React dev site, when we click links, the page does not reload. This is because it uses a single-page application, SPA, approach, so only the content that needs to change updates, making it faster and smoother. Now, let's check the Microsoft website. When we click links there, the page reloads because it is not a full SPA. The browser has to load a new page every time. I hope you now understand what an SPA is. After learning React, you can also work with React Native. React Native lets you build mobile apps using the same React skills. Now, let's discuss the prerequisites for learning React. You should have a basic understanding of HTML, CSS, and JavaScript before starting. We will start the installation. First, install Node.js. Then, install VS Code. Finally, set up a React project using Vite. Open your browser and type Node.js in the search bar. Then go to the official Node.js website to download and install it. Click on the button that says Get Node.js. Current LTS version is 24.13.0. LTS stands for long-term support. It means this version of Node.js will get updates and fixes for a longer time. Click on the Windows installer to download Node.js for your computer. Open the setup and keep clicking Next. It's an easy installation. Click Next and check the box to agree to the license agreement. The installation will take a few minutes, so be patient. The installation is complete. Now, open Command Prompt to check the Node.js and npm versions. Type Node-v in CMD to check the Node.js version. As you can see, the version is 24.13.0, the same as shown on the Node.js website. Now, check the npm version by typing npm-v in CMD. The npm version is 11.6.2. Remember, Node.js and npm have different version numbers. Now, we will install VS Code. Search VS Code in your browser and open the first link. Now, download VS Code for Windows. VS Code is already installed on my system, so I won't install it. It's very simple, and I hope you can install it easily too. Now, we will create a React project using Vite. Vite is a tool that helps you quickly set up a React project. Even the official React documentation recommends using Vite. Open the official React documentation in your browser. Click on Learn in the React documentation. Next, click on Installation. Click Creating a React app. Scroll down to the bottom to the section called Start from Scratch. Here you can see it says how to set up a new React project using a build tool like Vite, Parcel, or RSPuild. We will use Vite for a project. Let's click on Vite. It will open the official Vite website. Click on Get Started. Scroll down to the bottom and copy the command to create a project. Latest means it will use the newest version of Vite available. Open CMD in the folder where you want your React project and paste the copied command. It will ask you to enter a project name. Type the name you want for your React project. Next, it will ask you to select a framework. Choose React from the list. Then, it will ask you to select a variant. Choose JavaScript or TypeScript, depending on what you want to use. Vite may ask if you want to use Roll-Down Vite Experimental. This is a new, faster bundler, but still in beta and can cause problems. Choose No to keep things stable. Next, it will ask if you want to install dependencies with npm and start the project now. Choose Yes to install and start a React project. It will take some time to install the dependencies, so be patient. After installing the dependencies, your project will run on localhost 5173. Let's close it for now. We will open the project in VS Code next. Open CMD in your project folder and type code. This will open the project in VS Code. Open the terminal in VS Code and type command npm run dev. This will start your React project. The project is running on localhost 5173. Let's open it in the browser to see it live. It's working perfectly. As you can see, the code you see on the screen comes from App.jsx. Now, let's edit App.jsx. First, remove all the existing code in App.jsx. Now, add an h1 tag in App.jsx. Add text React 19. Add Learn to React 19. This will display Learn React 19 on the screen. As you can see, it is now showing Learn React 19 on the screen. Now, let's discuss the folders and files in a React project. Open the index.html file. Inside index.html, you will see a div with the ID root. This is where our entire React application is shown. You will also see a script tag that loads main.jsx. This file starts the React app and connects it to the root div. Now, open a main.jsx file. In main.jsx, React finds the root div from index.html. Then it renders the app component inside that root. Strict mode helps us catch mistakes while developing. Now, open the App.jsx file. App.jsx is the main component of our React app. Most of our work will be done inside this file. JSX stands for JavaScript XML. Now, open the package.json file. Name. This tells us the name of our React project. Version. It shows the current version of our React project. Scripts section has commands we can run. Dev starts the development server. Build creates a production-ready version. Lint checks for code errors. Preview lets us preview the build locally. Dependencies section lists the packages our project needs. Dev dependencies section lists tools we use while developing. These are only needed during development, not in the final website. Dependencies are needed for the app to run, while dev dependencies are only needed during development. When we install a new package, it is added to package.json, and the package files are saved in the Node_modules folder. You can also see the React DOM folder inside Node_modules. Here's an important interview question. Why does package.json show only a few packages, but the Node_modules folder has a large number of folders? It's because each package can have its own dependencies, and all of them get installed in Node_modules. Now, open the Vite.config.js file. This file tells Vite how to build our React project. The plugin React helps Vite understand React files. Now, open the ESLint.config.js file. This file sets the rules to check our code for errors and best practices. Now, open the .gitignore file again. It lists files and folders that Git should ignore when tracking changes. Node_modules should be in .gitignore. It contains all the installed packages, which are large and can be reinstalled anytime using package.json. Now, open the app.css file. This file is used to style your React components. Now, open the index.css file. This file contains global styles that apply to the whole React app. The src folder contains all the main code files for our app. Files outside src are configuration files used by tools like Vite, ESLint, and Node. The public folder contains static files like images, icons, or the index.html file. Assets is used to store images, fonts, or other files that our React app needs. Assets folder is inside src and processed by React or Vite, so you can import files directly into your code. Public folder is served as is, without processing, and you can only access files using their URL paths. Here's an important interview question. React is a library, while Angular is a framework. Why? React focuses only on building the UI and leaves other things like routing or state management to separate libraries. Angular provides a complete solution with everything built in, like routing, forms, and HTTP. Now, we will cover two important topics: components and import and export. A component in React is a reusable piece of the user interface. It lets us split the UI into small, manageable parts. Let's understand components with a diagram. This diagram shows how a React app is divided into components. Each section is a separate component, like header, sidebar, content, and footer. Instead of writing everything in one file, we break the UI into small, reusable components. Each of these components can also contain other components inside it. This is called a component hierarchy and helps keep the app clean and organized. App.jsx is the root component of our React application. All other components are rendered inside it. Now, open the main.jsx file. Here, we're using the app component as a self-closing tag, but you can also write it with an opening and closing tag. Let's write app with opening and closing tag. Now let's test it in the browser. You can see it also works perfectly with an opening and closing tag, just like the self-closing version. In React, component names must start with a capital letter. Let's try making the first letter lowercase. Watch, React won't recognize it as a component, and it won't work. See, it's not working with a lowercase first letter, but let's inspect element to see error. You can see the error. The tag app is unrecognized in this browser. If you meant to render a React component, start its name with an uppercase letter. This is why React requires component names to begin with a capital letter. Now let's fix it by making the app component start with a capital letter everywhere. Once we do that, React will recognize it correctly and everything will work. You can see now it's working again, because the app component starts with a capital letter everywhere. Now let's talk about Fragment in React. React Fragment lets you group multiple elements without adding an extra HTML tag to the DOM. Let's apply a fragment now. Now let's add a paragraph tag inside our fragment. Let's test in the browser. You'll see the paragraph renders correctly and no extra div is added to the DOM because we're using a fragment. Right-click and inspect the element in the browser. You can notice the paragraph is there, but the fragment itself doesn't create any extra HTML in the DOM. Now let's remove the fragment. You'll see an error because React components must return a single root element. You can see the error. Adjacent JSX elements must be wrapped in an enclosing tag. Did you want a JSX fragment? This happens because React requires a single root element, which is why we use fragments. Let's add the fragment back to fix the error. Now our JSX has a single root, and everything renders correctly again. Now, instead of using a fragment, let's wrap the elements in a div. This also fixes the error, but it adds an extra node to the DOM. Let's test it. Right-click and inspect the element in the browser. You'll see the div wrapping the h1 and p tag unlike a fragment. This adds an extra node to the DOM. Now let's remove the div and the p tag, leaving just the h1 element in our JSX. Let's test it in the browser. You'll see the h1 renders correctly on its own, no fragment or extra div needed. Now let's dive deeper and check the component in detail. Let's create a new component called footer inside the same app.jsx file. In header1 tag, show text footer. Now let's use the footer component as a self-closing tag inside app. Oops, we're seeing an error because we forgot to wrap the JSX in a fragment or another enclosing tag. React requires a single root element. Now let's test it in the browser. You can see the footer is showing perfectly, rendered by our footer component inside the app. Now let's rename the footer component itself with a lowercase first letter. You'll see React won't recognize it as a component anymore. You can see in the browser that the footer component is not showing. React doesn't recognize it because the component name starts with a lowercase letter. Now let's create a normal function called subtract to show the difference between a regular JavaScript function and a React component. return 20-9 so we can see the result in the app. Now let's add a paragraph in app and call the subtract function inside curly braces to display the result. Let's test in the browser. You'll see the paragraph showing result 11, which comes from our subtract function. So to summarize, a normal function returns JavaScript values, while a React component returns JSX. And remember, component names must start with a capital letter for React to recognize them. Now let's create the same footer component in a separate file instead of inside App.jsx. Now let's copy the code we had for the footer inside app and paste it into footer.jsx so the component works from its own file. Now that our footer component has its own file, we just need to import it and use it in App.jsx. First, we export the footer component from its file using export default footer so it can be imported elsewhere. We can have multiple components in a single file, but only one of them can be exported as default. The others need to be exported as named exports if we want to use them elsewhere. Now let's open App.jsx and import the footer component from its file so we can use it. Now let's use the footer component as a self-closing tag inside App.jsx. Let's test it in the browser. You'll see the footer component renders correctly from its own file. Now let's create a new component inside footer.jsx called footer2. This will show how we can have multiple components in the same file. Now let's try exporting footer2 as the default export instead of footer. You'll see an error because a file can only have one default export. Now let's remove export default footer2 and keep only the default export for footer. Now let's export footer2 directly by adding the export keyword before the function. This makes it a named export. Now let's open App.jsx and import footer2 using curly braces since it's a named export. Now let's use the footer2 component as a self-closing tag inside App.jsx. Now let's test in the browser. You'll see both footer and footer2 components render correctly using the self-closing tags. Now let's discuss the different types of exports in React. This is default export. A default export lets you export a single main component or function from a file, and you can import it without curly braces. This is named export. A named export allows you to export multiple components or functions from the same file, and you must import them using curly braces. Now, let's discuss the types of imports. Default import, used for default exports. You don't need curly braces and can name it anything you like. Named import, used for named exports. You must use curly braces and the exact exported name. You can also export variables, not just components or functions. This lets you share constants, objects, or any JavaScript value between files. Now let's open footer.jsx. Now let's create a constant in footer.jsx called website name and set it to React 19. Now let's open App.jsx and import the constant website name from footer.jsx using a named import. Now let's add a paragraph tag and display the website name constant inside curly braces. Now let's test it in the browser. Oops, it's not showing anything because we forgot to export the constant. Let's add export to website name in footer.jsx. You can see the paragraph now showing website name, React 19 along with the footer and footer 2 components. I hope this helps you understand components, fragments, and how import and export work in React. Now, let's discuss JSX. JSX is a syntax that lets us write HTML-like code inside JavaScript. Let's understand JSX with the help of an image. On the left, you have JavaScript. In the middle, you have HTML. When you combine JavaScript logic with HTML-like syntax, you get JSX shown on the right. JSX lets you write UI code that looks like HTML, but it actually runs as JavaScript. That's why you can use things like variables, functions, and expressions directly inside tags using curly braces. So in simple terms, JavaScript plus HTML syntax equals JSX, and JSX is what React uses to describe a UI. Let's look at an example. Hello name in H1 tag is HTML. Name is JavaScript inside JSX. React converts this JSX into plain JavaScript behind the scenes. Let's look at how we used to write HTML and JavaScript before JSX. Previously, we used to write code like this, where HTML and JavaScript were completely separate. HTML was responsible for the structure, and JavaScript handled the logic. JavaScript had to manually find elements in the DOM using things like IDs or classes. Then it updated the content step by step. React with JSX removes this mess by letting us write UI and logic together without manually touching the DOM. Now, we will perform different operations in JSX. Let's create a variable in JSX. We create a variable called course name and assign it the value React 19. Now, display it using curly braces. Curly braces let us use JavaScript values inside JSX. Let's test it in the browser. As you can see, it's displaying React 19 on the page. Now, we'll perform a subtraction operation right here in JSX using JavaScript. Let's create a variable a and assign it the value 40. Next, let's create another variable b and assign it 30 using let. Now, we'll display the result of a minus b in JSX using curly braces. Now, let's test it in the browser to see the subtraction result. As you can see, the result is 10. The subtraction works perfectly. Now, let's create a function called displayCourse. Inside the function, we'll return the text React 19. Now, let's display the result by calling the function inside curly braces. Now, let's test it in the browser to see the output. Perfect. As you can see, it's showing React 19. Now, let's create a function that takes parameters. Let's create a function called multiply that takes two parameters, x and y, and returns their product. Now, we'll display the result by calling multiply with 10 and 3 inside curly braces. Now, let's test it in the browser to see the multiplication result. Perfect. As you can see, it's showing 30. Now, let's apply conditions using nested ternary operators. First, let's create a variable age and assign it the value 10. Now, we'll use a ternary operator on the age variable to apply some conditions. If age is less than 13, it show kid. Next, if age is less than 60, it show young. And if neither condition is true, it will show old. Now, let's test it in the browser to see the result. As you can see, it's showing kid because the age value is 10. Now, let's change the age value to 65 and test it again. As you can see, it's showing old because the age value is 65. Now change value to 40 and then test it again. As you can see, it's showing young because the age value is 40. Now, let's implement an object. Let's create an object called empObj with two properties, name as John and department as HR. Now, we'll display both properties of the object in JSX using curly braces. First, let's display the name property. Next, we'll display the department property. Now, let's test it in the browser to see both properties. As you can see, both properties are displayed, John and HR. Now, let's implement a string array. Let's create an array called department. Now, we'll assign the values HR and IT to the department array. Now, let's display the array using an unordered list with list items. Create an unordered list. Now, we'll use map function to loop over the department array and display each item. For each item in the array, we'll return li element. Now, let's apply the key to each list item so React can keep track of them properly. Now, let's test it in the browser to see the array displayed as a list. As you can see, both items, HR and IT, are displayed in the list. Now we'll bind input attributes like type and value with variables to make them dynamic. Let's create an input field with type set to text. Now, let's add the value property and bind it to the course name variable. Now, let's test in the browser to see the input value. As you can see, React 19 is showing in the text box. Now, we'll make the input type dynamic by controlling it with a variable. Let's create a variable called input type and set its value to text. Now, we'll bind the input type variable to the input's type attribute using curly braces. Now, let's test it in the browser to confirm it still works. Perfect. It's showing a text box as expected. Now, let's change the input type value to checkbox and test it in the browser again. Perfect. It's showing a checkbox as expected. Now, let's change the input type value to radio and test it in the browser again. Perfect. It's showing a radio button as expected. Now, we'll implement a function and trigger it on a button click. We'll see both a normal function and an arrow function. Now, let's create a function called showCourse. We've declared the function and now show an alert with React 19. Now, let's create a button and bind the show course function to its onClick event. Now, let's test it in the browser and click the button to see the alert. Perfect. It's showing an alert with React 19. Remember, in JavaScript, the onClick event should be all lowercase, so let's change it to lowercase. Now, let's test it in the browser. It won't work if we use lowercase onClick in JSX. It's not working. Let's inspect the browser console to see the error. As you can see, it says invalid event handler property, onClick. In JSX, it should be onClick with a capital C. In React, we use camel case for events like onClick, onChange, and other events. Now, let's add parentheses to the function named showCourse in the onClick event. Now, let's test it in the browser. You'll see the alert shows immediately on page load. This happens because in the React context, adding parentheses calls the function immediately instead of waiting for the click. Now, let's create an arrow function called CourseVar. Inside this arrow function, we'll show an alert with React 19. Now, let's create a new button and bind this arrow function to its onClick event. Now, let's test it in the browser and click the button to see the alert. As you can see, when we click the button, it shows React 19. Now, let's add a parameter to the arrow function so it can alert based on the value passed. Now, in the onClick event, we pass a parameter using an arrow function. Now, let's pass React as the parameter, so when we click the button, it will show React. Now, let's test it in the browser and click the button to see the alert. As you can see, when we click the button, it shows React. Now, let's change the value to Angular, so when we click the button, it will show Angular. Now, let's test it in the browser and click the button to see Angular. As you can see, when we click the button, it shows Angular. Now, you should have a clear understanding of normal functions and arrow functions in React, both with and without parameters. In React, state is a way to store data in a component that can change over time. When the state changes, React automatically updates the UI to reflect those changes. Hooks are special functions that let you use React features, like state and lifecycle methods, in functional components. The most common hooks are use state to create and manage state, use effect to handle side effects like fetching data or running code on component updates, use ref, use context, and others for more advanced cases. So basically, state holds your dynamic data, and hooks let you work with state and other React features and functional components. Now, let's create a component called course. We'll use this component to understand state and hooks in React. Now, let's add the code inside the course component. Inside the component, we return a fragment using empty angle brackets. Now, add export default course so this component can be used in other files. Now, let's use the course component inside the App.jsx component. First, we import the course component into App.jsx so we can use it there. Now, remove all the code inside the fragment in App.jsx so it's completely empty. Now, we'll use the course component by adding it inside App.jsx. Now, inside the course component, let's create a variable called course. Now, assign the value React to the course variable. Now, display the course variable using curly braces in JSX. Now, run the project using the command npm run dev. Now, open localhost 5173 in the browser to see the output. As you can see, the course component is rendering on the screen. Now, let's create a button with the text change course. We'll use this button to change the course value. We accidentally created the button in App.jsx. Let's move it into the course component where it actually belongs. Now, let's create an arrow function called changeCourse inside the course component. Now, let's change the course value to Angular using this function. Now, let's bind the changeCourse function to the buttons on click event. So clicking the button updates the course value. Now, let's test it in the browser and click the button to see the course value change. As you can see, when we click the button, the value isn't changing yet. Now, let's add console.log inside the changeCourse function to check if it's triggered and the value is changing. Now, let's open the browser console and test it to see if the function is triggered and the value changes. As you can see, the value changes in the console, but it's not reflected in the UI. In React, values only update in the UI when the component re-renders. Normal variables don't trigger re-renders, so to change values dynamically, you need to use state. When a value changes in state, the component automatically re-renders. To use state in a functional component, you need to import it from React using hooks. Now, let's remove the course variable since we'll manage it with state instead. Now, let's import useState from React at the top of the component. useState is a React hook that lets you add state to functional components. In React, if a function starts with use, it's a hook. For example, useContext and useEffect are also hooks. Now, let's create state using course and setCourse. First parameter course is the state variable that holds the current value. setCourse is the function we use to update that value. Whenever we call setCourse, React re-renders the component with the new value. We provide the initial value for the state variable. In this case, it starts as an empty string. Now, let's set the initial value of the state to React. Now, inside the changeCourse function, use setCourse to update the value to Angular. Now, let's remove the old course variable since we're using state instead. Now, let's test the state in the browser and click the button to see the value update. Perfect. When we click the button, it updates the value to Angular. Now, let's see another example of state. Let's create show. Set show to control whether data is shown or hidden. Now, let's set the initial value to true, so the data is visible at first. Here, we will use conditional rendering. If show is true, display text React course in h1 tag. If show is false, it will render null, which means nothing will be displayed on the screen. Now, let's test it in the browser to see the conditional rendering in action. As you can see, React course is showing because the show value is true. Now, let's change the show value to false and test it again in the browser. As you can see, nothing is showing because show is false. Now, we'll update the show value when a button is clicked. Now, let's create an arrow function called handleHideShow. Now, let's create a button with the text hide show. Now, let's bind the handleHideShow function to the buttons on click event. Inside handleHideShow, use setShow to toggle the value of show each time the button is clicked. This way, clicking the button switches between showing and hiding the content. Now, let's test it in the browser and click the button to toggle the content. As you can see, the content hides and shows when we click the button. Now, let's move the button above the content for a better layout. Now, let's test it again to see the button above the content working properly. As you can see, it worked perfectly. I hope you're clear now that state and hooks are both important concepts in React. State lets components manage dynamic data and update the UI automatically. Hooks allow functional components to use state and other React features without writing class components. In React, props are like special boxes that let you send information from one component to another. For example, a parent component can give a child component a name or color using props. Now, we'll create a new component called employee, and we'll use it to understand props. Now, we create the employee function component and return a fragment from it. Now, let's display some text like employee inside it, so we can see it on the screen. Now, add export default employee, so this component can be used in other files. Now, import the employee component into App.jsx, so we can use it there. Now, use the employee component as a self-closing tag. Now, we'll create a variable whose value we want to show inside the employee component. Now, let's create a variable called empName and assign it the value John. Now, we want to display the empName variable inside the employee component. Now, let's pass the variable to the employee component using props. Now, open the employee component and receive the data using props. Now, add console log, props, inside the employee component to see the value passed from the parent. Now, open the terminal and run the command npm run dev to start the project. Now, the project is running and serving at localhost 5173. Now, open the browser's inspect element to check the console. As you can see in the console, the prop is showing as an object with a name inside it. In employee props, you can rename props to any name you like. Currently, we're using props. Let's change props to obj in the employee component. Now, let's test it in the browser to make sure the prop is still working with the new name. As you can see, it's working with the new name obj as well. Now, remove the course component so only the employee component remains. Now, we use conditional rendering. We'll show the employee component only if emp name has a value. Now, let's test it in the browser to see the conditional rendering in action. As you can see, the variable emp name contains a value, so the employee component is showing. Now, let's make the variable value empty and test it again in the browser. As you can see, nothing is showing now because the variable is empty. Now, open the employee component and use obj.name instead of obj to display the name directly instead of the whole object. Now, let's test in the browser to see the name displayed directly. Now, open the browser's inspect element to check the output in console. You can directly access the parameter using its name inside curly braces instead of using obj. Now, do the same in console.log to directly access the parameter using its name. Now, let's test it in the browser again to see the changes reflected. As you can see, the name John is displayed in the console. Now, let's display the name inside curly braces. Now, let's test it in the browser to see the name displayed on the screen. As you can see, the name John is showing on the screen. Now, let's create another variable called department and assign it the value HR. Now, let's pass the second parameter department to the employee component as a prop. Now, open the employee component and receive the department parameter as well. Now, remove the console log and display the second parameter department inside curly braces. Now, let's test it in the browser again to see both the name and department displayed. As you can see, John and HR are displayed on the screen. Now, let's implement props by passing an object to the employee component. Now, let's create an object called emp object with name as John, department as HR. Now, remove the separate name and department props and pass the whole emp object. Now, open the employee component and receive the emp object as a prop. Now, display emp name and emp department inside curly braces in the employee component. Now, let's test in the browser to see the name and department from the object displayed. Perfect. As you can see, John and HR are displayed. Now, we'll create an array of strings and pass it as a prop to the employee component. Now, let's create an array called department to hold multiple department names. Now, let's add the values HR and IT to the department array. Now, let's pass the department array as a prop to the employee component. Now, open the employee component and receive the department prop. Now, to display the departments, use unordered HTML list element inside the employee component. Now, use the map function on department to loop through the array and display each department inside the unordered list. Use item, index. These are parameters for the map function. Item is the current value. Index is its position in the array. Now, add a list item element inside the map to display each item from the array. Now, add the key attribute to the list item and assign it the index to help React track the list items. Now, let's test in the browser to see the departments displayed as a list. Perfect. As you can see, the departments HR and IT are displayed. This brings us to the end of React Part 1. I hope you understood all the concepts. In the next part, we will cover more advanced React concepts. If you're passionate about learning new technologies, make sure to subscribe to our YouTube channel, Tech Stack, and keep learning new skills. Thank you. And remember, consistency is the key to success.